So, how, how many of you have worked with Node.js or work currently? Raise their hand, please. Okay. JavaScript? Everybody, right? Otherwise, you'll not be here. Okay. Great. So, what can make a Node.js application slow? This talk will cover interesting stuff to improve your app performance and save your company money. Okay. So just before, I'm Rafael. I'm performance engineer at Uniform. I'm from Brazil, and I'm a member of some organizations in the open source, Fastify, Node.js for member, and also Clinic.js. Okay. So how many of you have already improved the performance of an app? Raise your hand. Okay. What is the feeling? It's good? Oh, when you work, yeah, that's amazing. But the feeling is critical, okay? But why performance is important, you know? So some of you may wonder why performance is important. So before understanding why performance matters, let's take a look at some common assumptions from developers, okay? The first one, when your response time is above 1 minute, usually the developer of 2 years of experience, the architect, senior architect will say, "Whoa, this is low, you know, I need to improve it a bit, like a bit." And when it goes from 10 seconds to 20, it will say, "Oh, you know, that's low, but you know, it's the entire application, then wait, that's okay." But when it goes from 1 second to 5 seconds, that's fine. They will say, I would say. And let's do it later. You know, let's add to a new task to do and let it to backlog forever. And when it goes to 300 milliseconds, they will say, "Oh, that's amazing right now. It should not improve more because it will be imperceptible by end users." But in fact, the human reaction time is 200 milliseconds. Once the 300 millisecond of threshold is exceeded, the iterations are often reported as sluggish, okay? So this data were taken from the human benchmarks study, which is a very good project. So if you have any question about it, check the project, it's amazing. So as you can see here, when you have a response time between 0 to 100 milliseconds, it will sound like instant for end users, okay? So, and the human the perception in the business. Often I see companies creating projects without a solid foundation in performance. So when the project is done, they start to realize that the performance is not good, you know? So when it happens, normally they don't have time to work in performance, you know? It's like, let it to one person and fix it in one day. It will not be possible, okay? So, for instance, in the business, Walmart found that when the load time jumps from 1 second to 4 seconds, the currency, I mean, the conversion decreased significantly. Like for every 1 second, the improvement, they got 2% of increase. This is a lot, okay? This is a lot of money, okay? So in Firefox, they increased the average in 2 seconds. Actually, they decreased the average in 2 seconds, and then the load increasing 50%. This is a lot as well. Okay, so also the performance is not only for end users, it's also about your company. When you are responding more fast, usually you are using less resource for a machine, so you are saving company money. Okay. So let's talk about some common performance issues that I have seen some consultants as on my journey as a consultant or as employee. Okay. First one, bad EISP. How many of you play games? Raise a hand. Okay. So in games you have the latency between the game, your machine and the server. Okay. And usually you have the bandwidth, you know, you have 100 of bandwidth, but you still have the latency high, you know? What is happening? It's because your ESP is taking the wrong route to reach the server, you know? Like if you use Vivo, if someone work in the Vivo, don't tell me, okay? Probably you are taking some hoops to reach the end of the server. So for instance, in this example, I have my server in United States, someplace there. And then I want to connect to this server, but my ESP send me to another continent, and then I go back to my server. And this takes time. The network takes time. The round trip takes time. Okay. So, but in this side, there's not to do from the server side. You know, you as an engineer, you cannot handle that because it's ESP from the end users. So that's expected. On the other hand, you have the bad server region. Okay. So for instance, you are from Brazil and you are going to connect to my blogs that is in the upside. You know, I will not say the country because I will miss. So it will take 1 second just to reach the server. It is not good, you know. So in the second is things obvious, you know. However, I have seen a lot of architects ignoring it. When you need to know your target. Like I know that my company have my the client only in Brazil, so my server should be in Brazil because the latency will be less. It will be a small latency, okay? So it's more expensive though, but the money is relative, you know. The other one is over-engineer. So let's take a look at this example. You have the application 1, you have the application 2, and you are spending 20 pounds a month, and your P99 is 100 milliseconds, okay? So it is acceptable, you are spending less money, so this is kind of expected. But someone joined to the project and say, whoa, this is not scalable, you know? What if the B goes down? And then what happens is that he creates a long architecture with a Lambda, with a needed BFF, with a decentralized database, with a message broker like Kafka or RabbitMQ. And then in the end of the day, you are spending a lot of more money and your P99 is still high. And in fact, if DB1 goes down, it's still in trouble. Okay, so everyone had this behavior in the past, but you know, you learn from the experience. And the other one is bad platform usage. You know that you may know that Node.js is non-blocking, okay? But it doesn't mean that there's just one thread. There's a lot of threads, but you run your code in a single thread, okay? So for instance, in this example, you will see that you are iterating and awaiting for an answer. So it means that it will run not synchronously, but you will wait for the first one to complete until the second one is done. Which means that, for instance, if you generate a graph of the load of your app in a Clinic.js tool that I will show a bit further, you will see that the CPU usage with some spikes, you know, like here you have some spikes, but there is a idle time, like a time that you are not using the CPU. And this is not good, you know, because you are just wasting resource of your machine, and then you are wasting time in the platform. Okay, and also if you check the event loop utilization, it will be very small. So okay, now what? How do we start optimization work? First thing that you need to do is establish a baseline. You should get all the current metrics, you should get all the benchmarks from your application and for further comparison, okay? So there's one thing very important when you are mapping observability of your app is that now not. For instance, you have a Grafana, like a graph that your CPU utilization, and you show that when some performance bottleneck arrives, you know that the average of the CPU is 10%. Any value different from that is word, so it's a point that you can't take a look, okay? And you have also the now. It's thing that you know that the increase of the API response might be related to a third-party provider, like the WhatsApp API, for instance. But you don't have the metrics, but you should have it mapped, okay? And the third one is unknowns. So for instance, you may not know that DNS resolution can be a bottleneck. So you are not checking it because you don't know, okay? But it is important to know it, even if you don't know. Okay, so in a graph, for instance, you have this architecture mapped. So you have in green the things that you know, and you know the average. And in red, you have the things that you don't know, but you know that you should be checking. So for instance, this is no knows, and this is no unknowns, okay? Next one, isolating the bottleneck. This is very important. So let's assume you are a soccer coach. Which player would you recruit for a team? You have the player A who kicked all the balls to the same wrong place, and you have the player B who kicked randomly but eventually hit the goal. Which one would you choose? Raise your hand. Okay, A, B, B, A, okay, A, A, okay. Yeah, the answer would be A, because you just need to teach A to kick to the left. So reducing variability is essential. You need to do it before doing optimization work. Otherwise, for instance, let's assume that you are benchmarking an application and you start to move your mouse like this, you know? You are moving your mouse during the benchmark. It will affect your benchmark, okay? You need to have, for instance, a happy place would be a dedicated machine to run your benchmarks. Otherwise, it will be very flaky, okay? So for instance, you are in a Zoom call with your coworkers, and then you start to debugging a performance issue in some application, and then you think, oh, I need to run my benchmark. I need to check how many requests I'm handling per second, okay? But if you are in a Zoom call, it will affect the benchmark, okay? So don't do that, please don't do it. I have tried in many workshops, and every answer is different, okay? So let's talk about some tools. AutoCannon. How many of you know AutoCannon? Nobody? Okay. Do you know Apache Benchmark? Okay, Apache Benchmark is pretty similar. Hello? So what happens is AutoCannon is a tool that generates loads for your application. For instance, you have an API. You have a simple API. And then you want to measure how much requests this API is handling per second. So you run this tool. This tool will send a lot of requests at the same time that will give you some result. Okay? All good? Next one, Clinic.js. This is one of the tools that I'm part on, and also is a tool that will help you to find your bottleneck. It will bring you some graphs, some interesting stuff that I will show a bit further. So, okay, let's go to the code. Let's assume the simple Express application, okay? You have the handler, that is a server post that every request that I receive in the post, in the root folder, in the root URL, I will update all the clients score, you know? And then I will send a reload word. And then my function of update all the client score is basically iterating of all the current clients and then performing update client score. This is pretty common. I haven't seen it a lot, okay? And in our case, the current client is just an array with 4 clients. So assume that you have only 4 clients. If you run this application with AutoCannon, it will bring you just 10K requests in 20 seconds. This is very low, okay? Very low. If you run this application again with the Clinic Doctor, you will see that the CPU usage has some spikes, but as well has some idle time. This is not allowed in a performance application. Okay, so this is due to a bad platform usage. You are not using Node.js correctly. Okay, so we can be more smart in this case. Let's use promise.l. Okay, promise.l. You are just removing your 4 iteration, then you are mapping, and then you are running all the promises in the same time, and then you are getting 30K requests per second, per 20 seconds. You know, you are handling 200 more requests, so 200 in percentage, you know, more requests. That's good. But also you should be careful with proxy. Let's assume that now you have, instead of war, you have 1,000 clients. And what happens when you run it? You should not run it when you don't have a limit of the clients. You know, if you are getting all the clients from the database, for instance, you cannot measure how much client you have. So don't use promise.out when the promise length is unlimited. You know, you don't have the length, or even the length is too high. Okay. So, but if you run the autocannon with the 1,000 clients, you will see that it's 4K requests in 20 seconds. You know, we are stuck again. So, but why? You know, if you run the clinic doctor, you will see that the CPU usage is fine. You know, is almost is using every second of the profiling. You see that CPU is fine. It's doing work as expected. But the memory is not. Okay. Garbage collection is synchronous, okay? So V8 owns the garbage collection, and once you allocate too much promises in your data, in your application, the garbage collection needs to free this memory, okay? It means that, for instance, here we will see that you allocated a lot of memory, and then it goes down because the garbage collector runs. So your memory usage is now low, okay? But the garbage collector is synchronous. It means that it will block your event loop. When you are blocking your event loop, the event loop delay increase and then your performance decrease. So don't block the event loop, and neither don't let the event loop delay increase, okay? Event loop is critical. I mean, you have seen this diagram. I think you have seen this diagram a lot in several times. It's available in Node.js. In fact, it's pretty important. You must understand how your code is executed by the platform, you know, and be able to optimize it. So GC is blocking the event loop for some time. So the lag, when you heard about event loop lag, is basically this one. Is the time that the close callback finish and then you start a new loop. So when you are blocking the event loop, you are blocking some of those phases, and then the loop don't start again, and then you don't take new tasks, and then you are stuck. Okay? So instead of using PromCL with an unlimited array, use limit or another library that does these slides. Okay? So there are several other libraries, so we need to check. It's up to you as engineer to do that. But this is an example. We are limiting to only 300 promises per run. Okay? So yeah, this one you need to know. Don't block the event loop. Okay? This is very important. If you increase the event loop lag, your application just die. You know, this is because Node.js works like this. This is because the V8 handles it, okay? So, okay. I said a lot of things, but let's talk about some things now, okay? Let's talk about profiling. How many of you know profiling? Okay? 1, 2, 3, okay. So, okay, let's imagine a large code base, okay? You might have several functions doing CPU work, like just writing to the disk or reading for the disk. Just for instance. How you can see how many times a function is spending the CPU. Like this function is spending 90% of the time of this application in the CPU. So this function is hot. Okay, it's stroke profiling. Then I will show you Clinic Flame. Clinic Flame generates flame graphs from your application. It profiles the application and then show which function is the bottleneck or aims to. Okay. So for instance, in this example, the flame graphs is basically, you can read the flame graphs like the x-axis represents the combined percentage of time that a function is spending the CPU. It means that much larger means a function with more problems, okay? So when you have a small blocks, it means that the function is just doing its work, and this is expected, okay? And the y-axis, like this one to this one, is just the call sign. So, for instance, if you have this in the flame graph, you see that handle, call it dispatch, and then dispatch call it next, and then handle, and then app.get. Okay, it's just to centralize everything. Okay. So and the x-axis is just to check how much time it spends in the CPU. Okay, so as I say, the bigger block, the bigger block. Okay. So let's assume another application. Okay. So this is a more feasible example. The following code does two operations, some values, and then stringify a big object. So you have a big object. You cannot take a look at it. It's just create a big object. Okay, this is trivial. And then you have a function that some values. It iterates a lot of times and then some values and do some return. You know, just for example. And then you have a get function that only stringify your big object and then call the some values. So if you run your application with Clinic Flame, you will see that it will bring you that some values is the problem, okay? And as you know, as you have seen the code, this is a problem because you are iterating a lot of times. But also you will see that this block is missing, you know? There's a block missing here. What is happening? It's because the block is getting inlined. And I will explain a bit about inlined code in the next step, but just looking to this example, you will see, okay, some value is the problem. I need to work in this function and then I optimize my app. So before fixing the problem, let's talk about some low stuff like kernel tracing. I have added to the Clinic Flame a way to do kernel tracing. Like it will retrieve all the C++ symbols code from V8 for your machine, but it's only available in Linux, so macOS and Windows user don't care about that, you know? You need to do it in different way. But since your application is running, I would say that most of your production application is running Linux server, you can do it, okay? So basically, if you run Clinic Flame with kernel tracing flag, it will get all the source code from C++ symbols from V8, and then you will be able to see the missing part is the V8 JSON stringifier, a C++ function that is spending more time in the CPU. So you will see that some value is a problem. It is, okay? But the JSON stringifier is also a problem. And this is important to mention. JSON stringify and JSON parse are synchronous functions. It means that when you are handling big objects with those functions, it will block the event loop. So don't use that, okay? What? Oh, yeah. Okay, so I will skip some hard things here because we are out of time, but it will be available in my site, in every place. Those things is very good. But some tips: don't use the delete keyword. Okay, the delete keyword is terrible for the performance. It will delete the shape of your application or of your object and then decrease the performance. Also, Express is not a good choice. Express is not maintained and very slow. Consider to change to Fastify. Okay, Fastify is very good, and I assume that we will take a look. Okay. And also, don't use private properties, okay? It was solved in the latest version of Node.js, but it's also a problem, okay? It is very slow nowadays. So instead, use just the underscore conversion or just symbol. And the last thing, how do we avoid regressions in a code base, okay? I have wrote a CLI to let you avoid performance issues in applications. For instance, you create an PR for your project, but you don't know if it will increase or decrease the performance, okay? So with this CLI tool, you'll be able to check that and it will avoid you to to send PRs to with regressions in a database. So for instance, it will run a benchmark in your application in comparison with the master branch and then check if there is a regression. And when there is a regression, it will block the PR, sending a request changes and telling basically just, okay, the router is low and Y is low, the request diff. And when it's good, you can check in the, it will just approve the PR, and then you'll be able to deploy your application. I assume will be not a problem, okay? So that's it. I mean, I think that I was out of time, but if you have any questions, let me know. I'm available mostly for Twitter, _ Rafael.js, and also in GitHub doing some work there. I hope not to break some applications, but let's see.